Hi, my name is Derk van Veen. I'm a database specialist at Adyen, and I mainly work on a partitioning framework. So, of course, this talk is about partitioning. So, if you're managing tables around 100 gigabytes and more, this is definitely the talk you want to see. All right, let's have some fun and dive in. Leveraging table partitioning for query performance and data archiving. Maybe I lied a bit about the title, but I forgot, or actually, I didn't know about the moment I did the submission. So, this is the title, and this is what you have to do it with. And today, I'm talking about partitioning. And I was surprised because I've been working on partitioning quite well now. And I was looking for examples around partitioning, and then I found the perfect example of partitioning. And actually, I didn't see this one coming, but the supermarkets are so good at partitioning. They do partitioning everywhere at many layers. And they also use it to stop people. Because when you enter the supermarket, there's the fruits department and the vegetables. And it's green and fresh. So everybody immediately slows down a bit. And then there's the first layer of partitioning because there's fruits and there's vegetables. And then in my supermarket, when I continue, there are the cans. And within the cans, there's a lot of partitioning. Like the cans they want to sell the best, they are at eye level. But then at eye level, there's more partitioning because the stuff they want to sell first is in the front, and the cans they want to sell later are in the back. So they're also using partitioning to manage the stock. And then I was trying to visualize a supermarket where all the products are basically scattered all around and you just get a map. And it's like cans. There are some cans on the left, some cans in the middle, some cans on the right. If you want the beans, they are on the top. It would be chaotic, right? So I was thinking like, what can we actually learn from supermarkets to store data more efficiently? How can we manage our data lifecycle management, like the stock? What is the data we want to give first, and what data can wait a bit? So that's what I'm talking about today. And I hope after this talk you will be able to make your queries faster, do your data lifecycle management better, and have lots of fun with partitioning. So I would say there are three reasons to do partitioning. And the first one is also a really bad one. But Postgres has a physical table size limit, which is 32 terabytes. If you are hitting 32 terabyte table limit, you are way too late with partitioning. I will not say I've been there, but don't go there. The good reason to do partitioning is, I would say, make your maintenance easier. So if your tables are getting around 100 gigabytes and more, it becomes time to think about partitioning. Because vacuum a big table, especially heavily updated table, is getting more intense. And you don't want to wait too long before you start partitioning when your maintenance is already out of control and then you have to do all the work under pressure. So by the time I would say 100 gigabytes, then maintenance becomes harder, and that's a good moment to start thinking about, how do I want to partition my environment? It's not about partitioning a table, it's about partitioning your entire environment. That's an important concept to get. And then finally, if you are having 100 gigabytes of data, you know you will get more data. If you get to 100 gigabytes, you will get to 200, to 500, to many terabyte size tables. So, and when you get to this table size, it becomes time to think about, when do I actually want to get rid of this data? So, how do I get the data out of my system, and how can partitioning help me with that? These are the three main topics for today. But let's cover the basics first. I would say there are again three types of partitioning. First one, it's list partitioning. And list partitioning, I would say it doesn't really tick the boxes because I can split my table in this case, in three pieces where I store Postgres, MySQL, and DB2 in separate partitions. But if my data was already growing a lot, these partitions will also grow a lot. Right, I may have slowed it down a bit, but it's still not sizable, I would say. So if you look at, is this long-term ease of maintenance? Not really. Is it helping me with if with data lifecycle management? Also, not really. So for me, list partitioning, maybe it's nice for some people if you want to do some reporting, but in general, I would say it's not the way to go. The second one is hash-based partitioning. And for some reason, developers love hash-based partitioning. So you have some random value, you do some magic, and then you have some remainder left. And based on the size of this remainder, you store your data in partition 1, 2, or 3. And this seems to be a nice way to split your data. And when you're under heavy insert load, the insert is spread over all the boxes. And that's kind of a nice thing. But then think about what happens if I want to double the amount of partitions. Then suddenly the remainders are all different. So there's no other way for me to redistribute all my data over all new partitions. What if I have collected 100 terabyte of data over these partitions and now I want to redistribute this data over the new number of partitions? The impact on the system would be huge. So it seems to be scaling well, but it actually doesn't scale well. And there's a second thing I don't like about hash-based partitioning, because a hash is a random thing. And if you're inserting into an index at all kind of random places, you are inducing a lot of full page writes for these index pages, and that's just hard. So again, hash-based partitioning seems nice, but for me, doesn't tick the boxes. It's not the way to go. So, well, this is only the third option out of 3, so this must be the box I need, right? Does it help me to get an infinite number of partitions? Yes, it does, because it's a range. It goes from 0 to a billion, or it goes from January 1st to January 31st. And I can always create new partitions in my range. And within Postgres, before you get to the theoretical limit of the number of partitions, you are very well on your way. And also, does it help me with data lifecycle management? Yes, definitely, because all the data is nicely together within the partition. So this partition is always older than this partition, which is really nice. So I would say the most natural way is to partition by dates. A date fits a nice time frame. We humans are good at this. So in this case, I have partitioned from January 1st to February 1st. The lower boundary is always included, the upper boundary is always excluded. And this works really well for example, PII data, where you can not keep your data around for over 5, 7, or 10 years, depending on where you collected this data. So if you want to get rid of files after 5 years, this is a really easy way to do it. So let's see how this works. Let's say I created a table with 3 partitions, and all of these partitions are empty at the moment. But of course, this is how life goes. At some moment, data will be inserted in my partition. Now I have only 2 partitions left, which are not in use, and I don't like it. So what I do is I will create a new partition, because I always want to have some partitions in reserve. So if I'm not creating new partitions for some reason, I always give myself some slack. I always have reserve space for incoming data. And then this space basically fills up, right? I get more and more data coming in, my partitions are filling up, and at the bottom I have my empty partitions. And at some moment in time, I have some nice window, and this is all the data I want to keep. But the data which is older than this window, I no longer need. And of course, you can write a cleanup job, and this can go through all of your data and then delete it. And then hopefully your cleanup job is as sufficient as the data which is coming in, so you can actually keep up with all the incoming data. But it's actually way easier to say like, hey, my upper boundary of this partition, it's older than, in this example, 10 days. So these are probably log files. I don't want to keep my log files forever. So if my log file is older than 10 days, the upper boundary of my partition is older than 10 days, I know I don't need this information anymore. So I just detach this partition from my parent table. I on purpose say detach the partition from my parent table because I don't want to delete it immediately. I'm the one who created this function, who's doing the work, and I know I make a lot of mistakes. So I rather detach it first and then have some cooldown period before I actually delete data. Because reattaching a partition is really easy. Restoring the partition from a backup is a lot of work, and that's something I don't like. And I created a solution for date ranges, and it's worked like a charm. And I was really pleased with myself, even though it was a very simple thing to do. And I was like, I will do the same thing for integer partitioning. And I was like, do I really have to do this? It's kind of boring. I will manage. But let's pretend these are integer partitions. I was like, all right, I can look at the total number of partitions, and if I have 9, I can get rid of the 10th. But then I was thinking like, what happens if the range of a partition becomes half of the range because of whatever reason we change the size of the partition? Then if I would rely on the number of partitions, I would suddenly throw away data I would still need. So this was kind of a tricky option and I didn't like it. Then I was like, well, maybe my partition has a nice date column and I can look at this date, but then not all tables have a date column I can use. So that's also an option I don't really like. Well, and then I try to look at the number of active partitions. And then for me, an active partition is a partition which actually holds data. And then I was like, yeah, but what if there's a error in either my calculation or in an application, and we suddenly insert data which is already in the future? Then suddenly I would drop way quicker partitions from the past. So again, this option was kind of tricky. And then I was left with, yeah, maybe I can do this based on the creation date. But again, what does the creation date even mean? And maybe I do some maintenance, I do some trickery, I swap partitions. So creation date is also not good enough. And I was like, well, I can just create a metadata table. But then what do I actually put in the metadata table? Because I already discarded all the options I had. So it turned out not to be so easy. And then I came up with a new plan. I can run a query against every partition I have. And if this query has to return a date. And if this date is older than the window I specified, that for me is the sign I can actually detach this partition. So how would that look like? Someone just provides me a query, someone who actually knows more about the data than I do. And I just run this query against all of my partitions. And this is the way how I can decide I can get rid of this partition or I need to keep it around for a while. And I would say this is a very fail-safe option. So finally, I'm now able to do lifecycle management based on a integer. The next important thing, joining tables. Maybe this is no, not maybe, this is definitely the most important thing if you're working with partition tables. Because we are working with a relational database, right? And most tables have a primary key, which is some kind of a technical key, probably an integer. And we want to join based on this integer because if you partition, the primary key has to be part of the partitioning key. And I only want to do a single layer of partitioning. For me, that's already hard enough to manage. So I don't want to go to 2 layers of partitioning. So I only have a single partitioning column. And then joining becomes really important because this is why I said leveraging query performance with partitioning is important, but it's actually the other way around. If you mess up your partitioning, the query performance is dreadful. And I learned this the hard way. So I learned if I improve my partitioning, the query performance goes up. And it goes up like 50 times, which is a lot, but only because I screwed it up in the first place. So how does partitioning and joining work? I've a trivial example, table A and table B, and they have a primary column, which is C1, that's the column 1. And I have some trivial query, select all the columns from table A, join table B on the primary key, where a value in the primary key is 500. Well, the optimizer knows this is in the first partition for both tables, so it will nicely go to table A, first partition, table B, first partition, join it. Everybody lives happily ever after. But then when queries become even slightly more complicated, something goes wrong. So I changed my where clause to where C1 is in two values. So now I expect the optimizer to use partition 1 and partition 2 for table A and partition 1 and table 2 for table B, because that's where the data lives that I'm asking for. But because of this where clause, it's nicely applied to table 1. That's something the optimizer can do. But then it scans all three partitions for table B, because it doesn't have a clue how the partitions match. And in this case, I have only 2 and 3 partitions. But in a real life environment, this might be 2 partitions and then 50 partitions. And if I join with table C, that's another 50 partitions. So instead of reading data from 6 partitions, I would be reading scanning indexes on 2 plus 50 plus 50 is 102 partitions. That's a lot of work, and that's how you get poor performance. So you have to align your partitions around the leading figure. What does this mean? These are some great leaders from the past, and I can tell you at the moment we have a prime minister in the Netherlands, and he's not related to any political party. And he's leading a government which consists of 4 political parties, but the leaders of the political parties are not part of the government. So, on one hand, we have 4 leaders making fuss on social media, and on the other hand, we have a partyless prime minister who's trying to make an omelette out of 4 eggs without breaking either of the eggs. I can tell you that's a mess. So, what does a leading figure mean when it comes to partitioning? I would say a leading figure is the figure that holds your data together. So within Adyen, we do a lot of payments. So it can be a payment identifier, because my payment identifier is what's keeping everything together. Everything is related to a payment. If you're working for a bank, this can be a bank account ID or a bank ID or a person. I worked in insurance companies, and then maybe the leading figure would have been a insurance object or a insurance policy. So it's if you're working with cars, maybe the car is your leading figure and all the parts are circling around the main car. You need something that really ties all your tables together. And maybe that means you need to denormalize your data. Well, so be it. It's a lot of work, it's a lot of hassle, but you have to go through it if you are partitioning your environment, because you will need the same partitioning key on all of your tables. But then, pay attention, this is what you get. So you remember this query with the complicated where clause, because now I partitioned my tables on the same column and all my partitions are aligned. So the bottom value and the upper value are all the same for all of my partitions. And then it still doesn't work. Well, why doesn't it work? Well, there's one more trick we need to do. We have to enable partition-wise join. This is using a bit more CPU cycles when it comes to query planning. And we are always afraid to mess up people's environments for no good reason. So if you want to do more efficient joining with partition tables, you have to turn the setting to on. And now if you run this query, you are only looking at the partitions you actually need. And this is a huge win. And to get a huge win, yes, you might need to do a lot of work. Maybe you have to include a new primary key into all of your tables, but 50 times faster queries, that's definitely worth it. And then I want to show you this because I think it's really cool. I have a new favorite data type, and I thought I was the only one not knowing about this, but apparently I'm not. It's the UUID v7. I will go through it very quickly. I was confused at first. There was this developer, Rick, he was coming to me and he said like, I want to do partitioning on the UUID v7. And I was like, no, Rick, you're a really smart guy. You know what you're talking about, but this is a really bad plan. So what is a UUID? Well, basically it's a very long hash, but the first part of the hash is a timestamp. So the first 48 bits are the timestamp up to milliseconds. And then the final 72 bits are basically random. So within every millisecond, you have 72 bits of randomness to make the value unique. So that's a lot of randomness. And you can do some really cool trick when it comes to partitioning with UUID v7s. So let's say my primary key is now a UUID v7, but that's two things. First of all, it's unique. And second, it has a date in it. So now I can combine the benefits from date partitioning and integer partitioning into a single value. So this is how my partition boundary would look like. This is basically a date, it's just randomness. So my partition starts at January 1st, 2025. Then if you did your calculation well, a UUID v7 is 128 bits, 38 bits for the timestamp and 72 bits of randomness. That leaves 8 bits for information about the UUID. That's the number 7 and 8 you see here. And for partition boundaries, I set all the randomness to 0, so I have nice clean boundaries. And now I can set the upper boundary for this partition as well. And again, this is basically a date, and I do this for all my other partitions as well. But think about this, UUID v7 boundaries are basically just dates. And now they are both dates, so lifecycle management is really easy, but they're also unique, so I can use this value for joining as well. So if you're about to start with partitioning and you can implement UUID v7s as a partitioning key, that's definitely the way to go. Then, finally, data lifecycle management. I think this is so cool. I'm so proud of this solution. We don't have it live yet, but we are working on it, and I just want to share it because it's so cool. You remember this picture, right? After 10 days, 5 years, 7 years, you want to get rid of your data. But actually, after a year, I don't want to have this data in my primary system anymore, to be honest, because the payment is something which is living very briefly, right? It's after a year, nobody wants to refund the hamburger they bought a year ago. So nobody looks at the data anymore. So I want to get rid of this data after a year. But the application might still need this data for reporting. So what I want to do is a trick. So I have some huge archive because our primary system is living on some really fancy flash disk really fast. But I have this data nobody cares about. I can move this data to a way slower system, which is way less expensive, and it's not burdening my primary system with all the maintenance load to keep this old data around. I want my primary system to be small and flexible and really fast and easy to manage. So what I can do now in this archive database, I create a table, a partition with the same boundaries as I had for my main partition. And I copy the data from my primary system to this archive system. And what I now can do is a trick. Of course, this copying takes time, but I don't care whether it takes a lot of time or not. I want it to be completed in time, which if this is a month of data, I have basically a month minus 1 hour to copy it, but it needs to be accurate. And then I can very briefly lock the table on the primary side, and I can make a switch here. I will create a foreign data wrapper which goes from my primary to my archiving system. So this is completely transparent to the application, but my primary system becomes way more smaller and easy to manage. And this is just really cool. And nobody knows about it. The devs don't know about this. It's just something I can do in the background. And for me, that's makes this really a lot of fun. So already time to talk about the summary. I don't have more time to talk about it. So the lessons from today, what do you really need to take home? I would say there's only one good way to do partitioning, and that's range-based partitioning. That's the only way you can scale forever. Data lifecycle management is easy, and it really helps to get maintenance easy on the long run. And if you have a choice, definitely go for the UUID v7 because it combines the best of both the worlds for date range and integer range partitioning. You can't do partitioning table by table. You have to partition your entire environment. So you have to find your leading figure and you have to implement the leading figure in all of your tables. That's the only way to get good query performance. So spend the time, spend the effort, and get your leading figure in place. And then when you have your nice stack of partitions, you can actually decide, do I want to remove my oldest partition and get rid of all the data in one go? Or do I actually move it to some archiving system transparent to the application and keep this data around for as long as you need it for whatever reason you need to keep your data around for? But it's not burdening your primary system and it's not burdening it's not you're not hiding it from your application. So this is a really cool thing. If you are doing partitioning and you are on a lot of load on your system, I would say you can use the LTM partitioning framework. It's free, it's on GitHub. You can use it for all your partitioning work. And if this talk was a little bit too fast for you today, there are I want to say blog, but blog doesn't really cover it. I think 4 very lengthy articles about how you can do partitioning, how to leverage partitioning, and basically it's a brain dump of everything I know about partitioning. So that's it for today, all the time I had. Thank you very much for listening and hope to see you around. Bye bye.